Hey love, how you doing? Good. How's your day? Good. Same. Okay, so just quick question is like, so the material that you need to cover is only that which you sent me on that one page, right? I'm sorry, like you were a little cutting off a little bit. Can you say that again? It's okay. Okay, no problem. I gotcha. So, what is it? Hold on. Like, let me pull that up. Um, yeah. So, like, like usually, like, I obviously, like, I looked at it, like, ahead of time and kind of like have a plan for the game and like, like I usually they're taught using the what's called the unit circle. So I don't know how you learn. Yeah, how did you learn to do this? Yep. Mhm. Yeah, beautiful language, beautiful language. Exactly, exactly. So I was gonna say that, but yeah, you beat me to it. Excellent. Like, continue. Which one? Okay, 12. Mhm. Yeah. Sorry. Say that. Say that last part. Yep. Okay. 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 Gotcha. So, but like like obviously the chart isn't available. She's not gonna give you that on the test, right? You don't. You well. Okay. It's helpful like as a way to double check, but like I'll like give you my approach, and I think this is a simple approach that does not require memorizing. And so let's get it. Okay. All right. So first is like problem one, right? So you have sine of 300. Now, what makes first before I do this, what makes an angle a quadrantal angle is that it lies on the quadrants. That's where the name comes from. So, um, like it's not the fact that it's in terms of pi versus in terms of degrees. If it has pi in it, it means that you're measuring it using radians. But you already know how to translate from degrees to radians and the other way around. So like I'm repeating myself, but what makes an angle a quadrantal angle is not that it has pi in it, but it's rather that it lies on the quadrants. So here are the quadrantal angles. So 0, 90, 180, 270, and if we come back, 0 is also known as 360, and 90 is known as what's 360 plus 90, like a lot, like 450. So 90 is 450, blah blah blah. So these are all quadrantal angles because well, we measure angles, positive angles anyway, counterclockwise. So as we go counterclockwise, if you end up like landing on a quadrant, which is like it's if we're like, let me do a different color. If we're like doing 60 degrees, 60 degrees would look like this, right? That's not on a quadrant. 60 degrees is approximately like that. That's not on a quadrant, therefore it's not a quadrantal angle. However, like all these other angles that I wrote are quadrantal angles. And of course, they also have like radian names for them. So 0 radians and 0 degrees, so it doesn't matter degrees or radians, 0 is 0. But the rest of them, we know, for example, like 90 is pi over 2, and that we know is because 180 is pi. And then 270 is 3 pi over 2, and 360 or 0 coming back is 4 pi over 2, aka 2 pi blah blah blah. So like it's a quadrantal angle whether we call it pi over 2 or 90. And again, what makes it a quadrantal angle is that when we go counterclockwise, we land on a quadrant. We're not in between quadrants, right? Okay. So enough said. Now, so your strategy for like answering sine of 180, sine of 270, blah blah blah. So sine and cosine, the trig values for quadrantal angles, your strategy is going to be slightly different than the rest of them. So these guys that are not quadrantal angles, I'm going to give you a tool, and like we'll talk about that, and I'm going to give you a slightly different tool. For these other ones, anything else you have will be like a way for you to double check your, the answer you'd get via whatever I'm going to teach you now or I'm going to show you now. Now, first thing first is, like before we even evaluate sine of 300, you're right, like ultimately angles like 300, blah, 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 they end up being about the reference angle, right? But yeah, before we even start, like remember I taught you a mnemonic last time, and it's ASTC. So all students take calculus or another stupid trig chart. However you choose to remember it, remember this, ASTC. Now, do you know the meaning of these letters? What are they telling us? Yeah, exactly. Here in A, all of them are positive. All positive. So that's sine, cosine, tangent, sine, cosine, tangent. But then, like, since 1 over tangent is cotangent, that's cotangent, right? Then cotangent is also positive in the first quadrant. 1 over cosine is secant. So secant is also positive. So all 6 of them, and cosecant, the reciprocal of sine, 1 over sine is cosecant. All 6 of them are positive in the first quadrant. That's what the A is telling us. What about the S? What is that telling us? Who? That's right, absolutely. But who else, therefore, automatically is also positive in that quadrant? Yes, exactly. The reciprocal of sine, his partner. So sine and cosecant are positive in the second quadrant. And the third quadrant, tangent is positive. Therefore, who else is positive in the third quadrant? Yeah, but notice, correct. Notice that what that means is the other 4, the ones that are not tangent and cotangent, therefore sine, cosecant, cosine, and secant are all negative in the third quadrant. Only tangent and cotangent are positive in the third quadrant. And then the fourth quadrant, cosine and secant are positive. The rest of them are negative. So you need to remember this. Other than that, this is very straightforward. Go back to the 30, 60, 90 degree reference, 30, 60, 90 special triangles. So I'll draw the 30, 60, 90 first. And then the other one is the 45, 45, 90 special triangle. So here's the 45, 45, 90. So this is 45, and this is 45. Obviously, the right angle is 90. Let's say, realistically, this is 30, and this is 60. Now, just to, make sure, check for understanding, what is 60 in radians? Yep, exactly. Excellent. Good, quick familiarity with all of these. What about 30 in radians? There you go. Bingo. Good job. So lots of progress from last time because I only taught it to you last time. Excellent. What about 45? Yep, exactly. So this 45 is also pi over 4. Now you need to remember the side relationships. So pi over 4. I'll write in a different color. So for the side relationships, let's say that this side of the 45 is 1. What can you say about this other side? Yes, exactly. If this side is 1, this is also 1. Exactly. Good job. Decisive. And what about the hypotenuse? It's okay. It's square root of 2. And you could just do quick Pythagorean. It's okay. A squared plus b squared, 1 squared plus 1 squared is equal to c squared. That says 2 is equal to c squared. Therefore, c is equal to the square root of 2. So you can get there, but just memorize this. So I said there's no memorization involved, only this little bit, which is memorizing your triangles and the ASTC. That's important. You need to memorize those. Now, on the 30, 60, 90, across the 30 is 1. I'll just tell you. And therefore, across the pi over 6 is 1. Across the 60 is root 3. And the hypotenuse is 2. Does that make sense? Yeah, now using these triangles, you can answer any question. For example, sine of pi over 6 is 1 over 2. Because, well, pi over 6 is 30. Across opposite is 1. And hypotenuse is 2. So sine of pi over 6 or sine of 30 is 1 over 2. Blah, blah, blah. Now, how is this helpful to like the task at hand, what we're doing right now? Well, it's tremendously helpful because like for 300, as you said, as you pointed out at the start, it's all about the reference angles, right? So first, map out what 300 degrees would be. This is 90, this is 180, this is 270. So you need to go a little bit more, but not all the way to 360. So you need to go 30 more beyond 270. So that means you have this. So this is 300 degrees. I drew the arrow counterclockwise to show that it's positive 300, right? We need to keep in mind, is it positive, is it negative, right? But now, this side, right, like this side that we land on is called the terminal side. We talked about that last time. I'm sure you retained that. This is the terminal side. And so to create a reference triangle, first a reference angle, and therefore a reference triangle, we said you take the terminal side and you drop it to the x-axis. Wherever it may be, you drop it to the x-axis and write a 90-degree angle there. Now, this triangle right here you have is a reference triangle. And as you can see, since you went 300, to get to 360, which is 0, you need 60 more. So the reference angle right there is 60. So then this triangle that I had shaded, that's a 30, 60, 90-degree triangle. That triangle right there. And so then label the sides appropriately from what you know of the 30, 60, 90. And what we said is across from the 60 is root 3, when across from the 30 is 1, and the hypotenuse is 2. So then now, when you answer sine of 300 degrees, you could just focus on this triangle. And so sine would be opposite over hypotenuse, which would be root 3 over 2. But then you also, in tandem, use the reference triangle and this guy, right? And so the ASTC, you know that only cosine and secant are positive in that quadrant. What we're talking about is sine. And so since our reference triangle is in the fourth quadrant, we know sine is negative. So you throw a negative sign in front of the root 3 over 2, and that's all she wrote. Does that make sense? Okay, so then this way you don't have to memorize anything. Now, since I did a lot of the talking in that part, I need you to do the talking in this question. And so next we're at cosine of 225 degrees. So talk to me. What should I do to start? Say that again. Yeah, exactly. I keep it like this. Don't write like cosine of that reference angle. Keep it like this and say equal, but draw this angle on the quadrants. So when we draw it, it's not quite 270, but it's definitely more than 180. So you land somewhere in the third quadrant. So you draw your terminal side, your terminal side, and from the terminal side, drop a perpendicular to the x-axis, and then figure out what this reference angle right there has to be. What is that reference angle there? Huh? Exactly, 45 degree. Draw the reference angle. So it's not the same as tan of 45. It's not the same as cosine of 45, but the reference angle is 45. That's why I don't want you to write equals cosine of 45. Because 45 would be like in the first quadrant. It's close, but you're right. Like it has to do with 45 in that the reference triangle. The reference angle is 45. Therefore, the reference triangle is also 40, a 45-degree triangle. Got it. So then, we either go back to what we had on the first page, this 45, 45, 90, or you just have this 45, 45, 90 in your head. And what we know is on the 45, 45, 90, this is 45, and we have 1, 1, root 2. So then you need cosine. So cosine is adjacent over hypotenuse, so that's going to be 1 over root 2. But you have to rationalize it, so you need to multiply by root 2 over root 2. When you do, the numerator becomes root 2, the denominator is 2, so you have now root 2 over 2. Okay, so your answer is root 2 over 2. The only thing you need to worry about is it positive or is it negative? And what do you say? Why? Yeah, exactly. Beautiful. Exactly. Like we're in the third quadrant. The reference angle and the reference triangle are in the third quadrant. So there, only tangent and cotangent are positive. So all the other ones, cosine, blah, 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 are negative, and therefore you throw a negative sign right there, and you're done. So, like I suppose we could do like, one for like the sport, but like, or two more, like, but otherwise, like, I think these kind of like are taken care of right now. Like, the ones that are not quadrantal. All right, I'll do like, yeah, sorry, I'll do more than a couple, but like I'll do it very quickly. Don't worry. So we'll definitely not need the full hour for this section. Like nowhere near it. Okay. But okay. So first is like cosecant, right? Cosecant. I'm doing number 4. Cosecant of negative 60. Well, what's different this time is you got to go clockwise. You got to go clockwise and 60 degrees. You're not going to be at where 270 would be. And 270, right? Like 270 is measured counterclockwise in the positive direction. But it's coterminal, and therefore it's the same as negative 90. So what I'm trying to say is like negative 60 doesn't go all the way to negative 90. If I draw the arrow, we went clockwise, so it doesn't land on 270. It's like you land somewhere here. Okay, got it. So then you already have your reference triangle right here. You just drop a perpendicular because you already landed at the terminal side going 60 degrees negative on the left. But it doesn't matter that it's negative 60 degrees. This triangle, the reference triangle, and the reference angle is positive 60 degrees. So you need to go back to your 30, 60, 90 degree triangle, draw it. So this is 30, this is 60, and so this is 1, this is root 3, and this is 2. Got it. And we're talking about cosecant. Cosecant is 1 over sine. So this is 1 over sine of negative 60. Again, we need to keep, the negative 60 as given, but a reference angle and a reference triangle can never be negative. So we're really talking about positive 60 because so what the negative 60 tells us is which quadrant we're on. But the reference triangle that we're going to use is this triangle. All right, so we know sine of 60 is opposite over hypotenuse. That's root 3 over 2. And so we go, but since sine is in the denominator, we go 1 over root 3 over 2. But then that's going to mean, since it's 1 over, it's going to mean 2 over root 3. And then now we have to rationalize since we have a root 3 in the denominator. So we go root 3 right there. So that's going to say 2 root 3 over 3. But then we are in the fourth quadrant, which means our answer is what? Why? Yeah, sorry for interrupting. Yes, only cosine and its reciprocal secant are positive there. We're talking cosecant. And so cosecant is going to be negative there. So you throw a negative in front of this, and that's all she wrote. So this is negative 2 root 3 over 3. And I think that's the answer that you have there. Yeah, I hope you're finding this more helpful than what you were given. And I'm not doing it just for novelty's sake. And so like this takes care of you like for a lot of them. So like I'm gonna skip to number 8, and number 8, and then we can talk about quadrantal ones. So for number 8, it says tan of 5 pi over 6. So tangent of 5 pi over 6. Now, first thing is, as you have done, like translate. Like I don't think your teacher is super nitpicky, but like first, don't say that this is equal to tan of pi over six. There's something very right about saying that, but it's not quite right, right? So don't say equal that or it's equal to 30. Don't say that. But what's right about it is that it's the reference angle. The reference angle is pi over 6 or 30. But first, like, we know 5 pi over 6 is 5 times pi over 6, obviously. But that means that it's 5 times pi over 6 is 30. So it's 5 times 30, so that's 150. The reason why we should make this kind of a translation into degrees is because radians are harder to visualize. Now that we have 150 degrees, we can visualize it very easily. So you could be like, all right, so we go, first of all, it's positive, so we go counterclockwise, and 150 will land you somewhere about there. So this is 150, aka 5 pi over 6. But then, now that you're at the terminal side, as we said, you drop a perpendicular to the x-axis and draw a right angle right there. This reference angle is what? Exactly, 30. The reference angles are always positive, and so it's pi over 6, or aka 30 in degrees, right? Okay, cool. So this is, again, the reference triangle now is about the 30, 60, 90, because as soon as one of the angles occupies 60 or 30, we know it's a 30, 60, 90. Because we create the reference triangles by dropping a perpendicular to the x-axis, meaning one angle is 90, so if this is 30, this one has to be 60. So opposite the 30 is 1, opposite the 60 is root 3, and then the hypotenuse is 2, and since you're talking tangent, tangent is opposite over adjacent, so that's 1 over root 3, rationalize, multiply by root 3 here and here, so that's root 3 over 3, and the only thing you need to keep in mind is it positive or negative? What do you say? Yeah, exactly. Tangent is positive in the third quadrant. We're in the second quadrant. So you throw in a negative sign right here. So you could do all of this work like away from like where the question is written. But finalement, at the end, be like equals negative root 3 over 3 over. Okay, got it. Now, I'm going to do one more of these. And I really do. I feel I don't need to do, but I'm like a little a paranoid person, as you know. So I want to make sure you're prepared for an A. By the way, did you get an A last quarter? Math, final grade? Okay. Okay, tell me next time. Find out and tell me. Okay, cool. And next is, I'm going to do 10. Sine of negative 3 pi over 4, okay? Again, like to visualize it, be like, that's negative, and then pi over, negative 3 times pi over 4. That's negative 3 times 45. That's negative 135 degrees. And so that means that, like, you know, we go clockwise firstly, and then, like, we're not quite at negative 180. We're, like, somewhere about here. So then, what is the reference angle, which we know we have to draw to the x-axis? So what is this reference angle for negative 135? Yeah, exactly. Why is your voice weak? Okay, it's okay. You just came back. That's okay. 45 degrees. Okay, fine. So then you drop a perpendicular here and be like, oh yeah, I'm going to label this. Like it's a 45, 45, 90, obviously, because that angle right there is 45. So then that's 1, 1, and then root 2. And since we're talking sine, that's opposite over hypotenuse. That's 1 over root 2. Rationalize it, meaning multiply by root 2 over root 2. That's going to say root 2 over 2. And now you have to decide, is it positive or negative? What do you say? Yep, and I'm not going to ask why. I'm convinced. You know why. Okay, cool, 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 cool. So I think this is the last of these that I want to do. So then the quadrantal angles. Now for the quadrantal angles, this is all you need to know, okay, bud? Like, so I could just be like memorize it, but it crossed my mind because I'm really tired, to be honest. And if it wasn't like my girl, like if it wasn't you, like I probably would have been like, I don't know, let's meet tomorrow morning or some shit like that. But Yeah, I needed to make sure, like, yeah, it's you, so like I need to take care of you. But anyway, like I could just say memorize it, but I'm not gonna say that. Now, like, look, remember, like last time your teacher was like, oh yeah, like if you have an x comma y here, right? You could draw a line there. This is r, and then you drop a perpendicular here, and so that's a right angle. This is x here. This is y there. So then for an angle theta here, we said that like sine of theta is equal to y over r. Cosine theta is equal to what? On this, yeah, you just need to look at this triangle. Yeah, you got it. Uh, and then it's clear you're tired. You kids are overworked, especially you. Tan theta. That's right. Y over x. Now, what I'm gonna say again, kiddo, love, you do this only for the quadrantal angles. On the quadrantal angles, just assume r is 1. This is the unit circle. A unit is 1. So when you're on a unit circle, the radius is 1. I don't want to elaborate because I want to keep the session contained, and I want to also tell you only that which you need, right? But r is 1, right? And you do this again only for the quadrantal angles. Notice when r is 1, I have sine is y over 1. I don't need to write over 1, so sine is simply y. And cosine, therefore, is simply what? It's okay. Sine, since we're saying r is 1, sine, which was y over r, it would become y over 1. But we don't need to write over 1, so sine just becomes y. And cosine, therefore, becomes what? That's right. For tangent, there's no r involved, so tangent will have to stay y over x. But then cosecant, the reciprocal of sine, is going to be 1 over y. Make sense? And then secant is going to be what? That's right. And then cotangent is going to be what? Beautiful. Thank you. We make such a great team. Great. Now, check this out. On the quadrantal angles, I'm going to get you started, but you help me label. I put dots. This here, since I said we're on a circle technically, even though I didn't draw the circle, to keep this focused, that radius is 1. So that point right there is the point 1, comma 0. Make sense? Yeah. What is this point right there? What's the coordinate of that point right there at 90 degrees? Is it 0, comma 1? You got it. This point right here. Negative 1, comma 0? Yep. This point right here. Yeah, you got it. You got it. You got it. So what you need to remember is not the unit circle, but that rather that sine is y, cosine is x, and tan is y over x. Simply that. Because then from there, I have confidence that you're going to know cosecant is a reciprocal of sine, so it's 1 over y. Secant is a reciprocal of cosine, so it's 1 over x, blah, blah, blah. And cotangent is x over y. You're going to know that. I know that. So just remember, sine is y, cosine is x, tan is y over x. Okay, but then this here, right? This here is 90 degrees or pi over 2. This here is pi. This is 3 pi over 2. This is 2 pi or 0. And you can keep going in circle, blah, blah, blah. So pi is also 3 pi. I didn't see any questions that said 3 pi. But like obviously 2 pi plus pi is going to get you back to pi, blah, blah, blah. Now, equipped with this, you can answer the questions very, very simply. Like, so number 11, it says secant of pi. But secant is the reciprocal of cosine. So that's 1 over cosine of pi. But pi is 180, therefore it's a quadrantal angle. But then we said cosine is x. So you come here, look at the x coordinate. X coordinate is -1. So cosine of pi is -1. So you have 1 over -1. So therefore secant is -1 also. Do you see how I did that? Yeah, so you remember sine is y, cosine is x, tangent is y over x. Otherwise, you just need to label the quadrantal angle 0, 1, 1, 0, blah, 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 appropriately as I've done in red here. So all you need to know is the red stuff, and obviously where your landing are for the angle. So like tangent of 2 pi, right? So that's the number 12. Tan of 2 pi would be like, well, okay, so tangent is y over x. You come to 2 pi, that's the 1 comma 0 coordinate. Y is 0, x is 1, so y over x, 0 over 1, or 0. Cotangent of 2 pi, on the other hand, cotangent of 2 pi, undefined, because cotangent would be x over y. And so you come here to 2 pi, and then cotangent is x over y, so that's 1 over 0. 1 over 0 is undefined. Although I didn't see any questions like that. Make sense? Unless you have questions, I'm done. I'm good. Okay. All right, love. Ace this, and yeah, like have a wonderful night, and yeah, like yeah, I think that's everything I want to say. Okay. You're very welcome, love. Have a good one, okay?